So one of your principles about AI that you absolutely have to internalize, I almost want to jump up and down a little bit so that, we take this one seriously, is that these are complex systems that make mistakes. Myth. I call this the biggest myth in AI. And that is, we've really come to a level of AI washing where it is very difficult to have an intelligent conversation about AI. And don't get all like, oh no, are the machines better than us? We're a tool-using species. The point of our tools is to make us better, right? You're not going to use a bucket to hold water if it doesn't hold water better than your hand does. And you know what's got better memory than you? Pen and paper. That's why you use it. So if you're worried that machines have better memory than you, that was done already. Hello, it is wonderful to be here. What a beautiful venue, what a beautiful theater, and what an excellent time to talk about AI. And if I can have my first slide, and our AI accelerated future. And the thing is, everybody is talking about AI, enough that at this point, if you're confused, you think that's just part of it. So I feel like I've been in the AI game for about 2 decades now. And first, I know that everybody is using their words a little bit differently here, but there are some mental models that I would like to give you to help you navigate this space and also to understand what the important questions are and what the important questions aren't. So when people think of decision-making and AI in a sentence, they tend to think of AI as a tool for decision-making, so that top one. But AI is also the product of decision-making. It is the product of some very subjective decisions that shape the nature of a system. And so if you're tempted to think like, oh, the AI is intelligent and it knows better and I should just go with whatever it gives me, what you're actually doing is you are accepting, for better or worse, the amplification of what a few people thought would be a good idea to automate. But that's a lot all at once, so let's go a little slower and get there together with analogies. Like this one. This is my absolute favorite analogy. If you guys were going to lift your phones and do it and share, it would probably be this. In fact, I'll get out of your way. Here you go. This is my quick guide to AI. So data would map to ingredients, algorithms to appliances in the kitchen, models to the recipes that you would learn if you were trying to invent a new dish, and then you would serve those dishes at scale. If you're an enterprise, you're Google, you're Netflix, whoever you are, you're serving them at scale, OpenAI. And then what we have that's very new, very, very new with generative AI is that individuals and smaller companies can take whatever those outputs are and use them for their own purposes. In other words, OpenAI, that serves you ChatGPT, doesn't actually know what you're going to do with it. If you're like me, you will try to make a poem about bananas by all of your favorite poets, because that's just the first thing you do with a new tool. And they might not have seen that particular application coming. And here, likewise, you have these outputs that now individuals are able to package up into whatever they want. Spray painted gold, call it art, stick it on the wall, whatever you like. Which is why I'm going to say a sentence that we don't hear often, and this is that my heart goes out to regulators. Because what we're looking at is a digital raw material. And it's hard enough to regulate normal raw materials. Now we've got digital raw materials. And just as in this whole situation, if something goes wrong, how interesting. See, let's say that over here, there's something wrong with something dangerous with those cookies. Is it the fault of whoever produced the ingredients? We know that if the ingredients are rotten, if you've got rotten eggs, it's not like you're going to make a beautiful Michelin quality cookie over here. So the data matters. But what do we know when we're on this side about what happened over here? No one's going to tell you, nor exactly what tools were used in the kitchen or how they were all combined, what the recipe was. You'll barely see this. So where is the fault if something goes wrong? It's a big, complicated system. Also, if someone tells you that they're in AI, please ask them which part of this. When we're talking at McDonald's scale, it's very hard for one company to do all of it. Yes, I worked for one that did, that was Google, but very few companies are in the whole business. So whenever someone says, I've got an AI startup, you ask them, which part? Which part are we working with? And that'll help get those conversations to be more sensible than they typically are. Next one, generative AI versus discriminative AI. I find it quite interesting when people are like, there wasn't a name for the other AI before generative AI came along, and now we need a name. No, folks, there were always names. It was called predictive AI or discriminative AI. And what it's about is situations where there is one right answer. So it's about getting the right answer and applying a label. One of my favorite right answer situations is when this guy, BJ May, he tweeted that he was very upset that his front door locked him out because it's supposed to identify a face, check that it's his face, unlock, but instead the door was trying to protect the house from Batman. So just because these things are about getting the right answer does not mean that they actually do always get the right answer. So one of your principles about AI that you absolutely have to internalize, I almost want to jump up and down a little bit so that, we take this one seriously, is that these are complex systems that make mistakes. Mistakes are possible. So it's very important for us to prepare for the mistakes. And luckily, the engineers of this door were prepared, so there's an option to put in a PIN code, so luckily, our hero here managed to get home. Now, discriminative AI with its one right answer style is different from generative AI, where the goal is to create a plausible exemplar. In other words, situations where there are many right answers. So you can see, I was illustrating my own slides. Look at me attempting to be an artist. And here is the earlier magic lamp, different versions of it that you saw. And then the tool is called Midjourney. After I asked for a pale magic lamp with magic smoke coming out of it, white background, then I get to choose, and if I don't like the one that is presented here, then I roll again, and I roll again, and I roll again 700 times until I get the one I want. By the way, if people ask, oh, is AI creative? What's happening behind the scenes is that the human creative is applying their taste to a lot of options coming out of software. So that's where the creativity is. It is in the having the taste, knowing what you're looking for, and making the selection. AI is just a tool, like a paintbrush is a tool. So here, we get a plausible exemplar of something that might be called a pale magic lamp with smoke coming out of it. Now, what do we see here that's really important? A plausible exemplar. That does not mean one right answer. That means that there are many right answers, many wrong answers, and in fact, a lot of that can be in the eye of the beholder. So if I ask for a poem by Shakespeare about bananas, I may be perfectly satisfied, and I'll ask 50 different times to something like ChatGPT. I'll ask 50 different times, and maybe of those 50, 49 of them, I'll be like, yeah, that's a pretty cool Shakespeare poem about bananas. And then I go ask a Shakespeare scholar, and they would say, awful, not at all. For me, my right answers are one thing. For them, their right answers are another thing. This is troubling. Troubling indeed. I'm not sure that our traditional approach to education prepares us for situations where there are many right answers. If you think about the classes that you took as a kid, some of them, sure, the essay classes had many right answers, but you didn't do those very often because your teachers didn't have time to grade them. There's a lot of right answer thinking. One right answer. Here we're in a situation with many right answers, where we have to apply judgment, sense, taste. Very human things. And the trouble with many right answers is when you use these tools for automation, you are expanding and extending and amplifying your own intelligence. That's why we call it decision intelligence, because we're trying to amplify the intelligence of our decisions rather than the stupidity, which is also possible to amplify, by the way. So, when it's a situation with many right answers, how do you think through, okay, which ones among all these different options that I'm going to get are correct? How much better is one than the other? And what about the mistakes? How am I going to relatively score those? It's a nightmare. It's really, really difficult to have that level of visionary judgment at scale and think through all the millions and billions of things that your system could do. Which is why your good old ChatGPTs of the world will write down there at the bottom, hey, it makes mistakes, disclaimer, don't sue us. Right. So what can you do with a thing like a ChatGPT? Many things besides my poems. You can say, write the Fortran code for the Fibonacci sequence, and boom, there's some Fortran code. Hands up, who speaks Fortran? One hand, two hands? Two hands, three hands. I like this audience, you guys are spicy. Now, I don't speak Fortran, so I have no idea what I'm looking at. So then, the skill I need is not to be able to ask for the Fibonacci sequence in Fortran, or being able to spell Fibonacci. Who needs that? Instead, the skill I need is to understand what I'm actually asking for, express it precisely, and be able to check whether what I got is what I wanted. That is a harder skill than we realize. Now, of course, I, as a recovering statistician, I'm just gonna throw that card on the table. Yeah, statistician. All about testing things and thinking through what it is that we actually can know and can't know from the data. How good is the answer actually? I find myself a little nervous for the world at large, because it is a hard skill to test complex systems. And if you don't know what you're looking at, how will you know where you can apply it next? But let's pause that thought, and let me ask you another question here. Is this AI? It's the strawberry model, the new one that dropped in September. It's the 01 preview. Is it AI? Who says yes? Who said yes? Fess up, come on. The yeses. Oh, you're so silent. Hands. It's very smart, because with the hand, only the people behind you can judge you, not the people in front of you. Whereas if you shout, it's 360. Yeah. Okay, so some people say it is AI. Who says it isn't AI? One hand is in the middle. Very nice. And who says she's probably messing with us? That's the popular answer. Correct. And this brings me to a myth. I call this the biggest myth in AI. And that is that we have really come to a level of AI washing where it is very difficult to have an intelligent conversation about AI. And what I mean by this is, absolutely everybody has the incentive to, if they can make even the tiniest argument that there's the tiniest little piece of AI somewhere in there, that the whole thing is AI. And what even is AI? We're going to get to that in a moment. But first, imagine that all the AI mathematics is this little white brick. The largest system that you are interacting with that calls itself an AI system has a lot more going on than just that one little white brick. And in fact, that little one white brick might not be the most important Lego piece that we're dealing with. There might be much more important code in there. That is not the AI piece. But what everybody wants you to look at is that white Lego block and ignore everything else. Coming back to our new 01 preview, our strawberry model, its claim to fame, its improvement on its predecessor, version 4.0, is that it is slower. And people are saying it's the era of slow AI. No, all it is some extra logic that's like, think it before you speak. And I use that word think in a tongue-in-cheek way. They, of course, use that word right on the screen. But what is happening there is some extra processing in order to check the consistency of the output before outputting it. So instead of just running in one direction, stop, go back, apply some logic to check whether or not things are still consistent and make sense. You do that as well. You're like about to have an opinion, and then you remember that you're smart, and maybe you should check the thing you're about to say quickly on Wikipedia before embarrassing yourself. Yeah. It takes you a little longer to come out with the fact. And sometimes you stop entirely and learn something new. That's fun, yeah. So this new model does exactly that kind of recursive checking. It's slow, it's more expensive, but because people have some dodgy digital trust habits and believe what they read and expect AI to be awesome and to do everything for them perfectly, it is a safer way to go about things, to sort of have a little bit of built-in checking logic. Is that built-in checking logic AI? We have more and more and more complicated systems that are put together, Lego constructions, some of which is the AI part, some of which isn't. What we're really dealing with, though, is complexity at scale. And so as people say, well, what's the way that we should analyze AI? Should we analyze it as starting with our, basic linear models in machine learning and then some neural network, and eventually it's basically a human? AGI. I say no. The ultimate thing is complexity. More and more and more complexity. And so seeing that, you can already start to ask yourself, well, how do I lead and how do I think? How do I reason? How do I work in a world that's more and more complex? Because the bottleneck is here. How much complexity can you absorb at once? Even if I take something that's very simple on its own, a 1 and a 0, and I arrange a whole bunch of 1s and 0s in front of you, will you make sense of what you're looking at? Will you make sense of what you can code with all those 1s and 0s? The computer that has better memory than you can, you get overwhelmed. So how do we work in such a world? That's the question. And to begin understanding this, we need the one slide on the foundational nature of AI. What's the difference between traditional programming and the so-called AI bits? Well, it's that when you are automating, it's always about automation, when you are automating, the job is to take a digital input, turn it into a digital output. Programmers, Fortran knowers, you do it via a recipe. And where does the recipe come from? Fortran knowers? From you. You make it up. You think about the task and you're like, it needs to do this, and then do that, and then do that, and then do that. And you handcraft this thing. That's traditional programming. We do that with humans too, and we teach humans. Sometimes you say, okay, in order to do this task, here's your manual. Step 1, step 2, step 3, step 4, don't screw it up. Right? Do exactly what it says. And if you're not familiar with, I'm quite a fan of the Exact Instructions Challenge on YouTube. You should check it out. It's a dad who asks his 2 children to come up with exact instructions for a peanut butter sandwich. And they don't do such a good job of this. And you see him following their instructions to comedic effect. But the point is, you can teach people with instructions. Sometimes, though, the instructions are hard to come up with. Like if we had to have the instructions for what to do with this pixel versus that pixel versus that pixel in order to identify whether this is a cat or not. If you had to give me instructions about what to do with every pixel, those would be some difficult instructions. They would overwhelm you. I mean, what is catness? Is cat a solid or a liquid? It's very hard. But what we do have is a lot of examples of cats, because the internet is mostly made of cat. So because we have so many examples, if we have enough of them and the processing power to handle them, maybe, just maybe, there are some patterns that we might be able to use the computer might be able to use to separate the cats from the not cats. Very nice. That's how this works. In one slide, the foundation of AI is when we explain our wishes with instructions, not with instructions, that's traditional programming, but with examples. And I like the words instructions and examples because they make us humble. When we say code and data, you just see the magic sparkles all around these words. It's so exciting. Let's bring us down a notch. You can explain yourself with instructions versus examples. So then I ask you, why would you want one versus the other? Is anybody who's brave and you're going to shout? Somebody brave, tell me. Why would you want to use instructions? Foretrainers, I'm counting on you. They are specific. I like that. What else? What's that? You build them, and then because they're written in human language, you can read them. What else? What's that? Accuracy depends how well you yourself know the task. I mean, I could write some really bad instructions if you wanted me to. They guide you. Okay, it's cheap. You get what you pay for. No, I love this, I love this. Okay, folks. Some of you are going to vibe with me, because I am a control freak. Instructions? Control. I know what I'm getting. None of this, hey, let me give you some examples. Oh, you go find the pattern. You go see what you think is important. You go figure it out. No. The control freak, you know exactly what you get. So instructions, traditional programming, is about control. Why would you give up control? It's easier to debug traditional code. It's easier to understand traditional code. Why give that up? Complexity, thank you. You got my next slide. Boom. I like it. I like this audience. Okay. It's control versus complexity. We need to appreciate that we have been working on the low-hanging fruit, the easy tasks. We have been solving things where the answer is short, the instructions are short, and that's powerful. We've managed to do a lot with that. But then some tasks, some situations, some problems, in order to solve them, the answer is so complicated it cannot fit in this bottleneck right here, in human memory. And so you have no hope of coming up with such complex instructions. The only way you can learn those tasks, or get those tasks learned, get those tasks automated, is through examples. Many, many, many. Using computers that have better memory than you. And don't get all like, oh no, are the machines better than us? We're a tool-using species. The point of our tools is to make us better. Right? You're not going to use a bucket to hold water if it doesn't hold water better than your hand does. And you know what's got better memory than you? Pen and paper. That's why you use it. So if you're worried that machines have better memory than you, that was done already. These are the 3 questions out of which an AI system is born. What is it for? This is what you should be asking of any system. What data is it using, and how do we know it works? All the other questions, they are fascination with a part of the system that, yes, it's important if you are working in our AI kitchen on building appliances. Sure, you need to know how the microwave works. But you as citizens, you as business leaders, you as leaders of your communities, you as buyers and users of other people's tools, you shouldn't be asking, how precisely does it work? How it works approximately is somewhere in there is data, patterns were learned, and there's a lot of other code going on. That's proprietary, so no one's going to tell you. The right questions you should be asking are these. Because these are where the system is born out of. And if the people in the room making decisions about how they were going to build their AI system to offer it to you chose one thing versus another thing here, you're going to get a very different system. So always ask, what is it for? How was success defined and scored? Remembering that with generative AI, it is much, much harder to define which situations should get a better score than which other situations. Many right answers is difficult to deal with. Number two, what data is it using? Data sets are like textbooks for the machine. And like textbooks, they come from human authors. Human authors who said, hey, this is important enough to record in our collective memory. Were they right? Would you agree with them? Would you record things the same way that they did? Anyone who pronounces data with a capital D, I think, is, do you realize that you're saying the same thing as, if it's written in a book, it must be true? No, of course not. Data sets are just some electronic scribbles that are easy to search at scale. So there's a lot of beauty there, the nature of collective memory, but also it could be useless data. It could be misleading data. Someone should be asking the question of, where did it come from? What was it for? Does it apply to my situation? If it's data about people, are these people living like I'm living? And then finally, the big one. How do we know it works? Because it's intelligent, because it has that word in it? No, of course not. Because we tested it. But who is we? Who tested it and how? How do we know that it is good for us? And this, of course, recovering statistician, close to my heart, this part is what you're going to need statisticians for. But more than that, you're going to need leaders to have the vision to say, under these circumstances, this big system is unsuitable. And under those, it is suitable. Who's got the skills to think that through at scale? Technology is in its teenage phase right now. Awkward, it's got braces, pimply. And one day it's going to be a lot better than it is now. And so I invite you to take it to its logical conclusion. What if it were perfect? What if it were easy? What skills would you need to have to lead in a world like that? They would be the skills of questioning. They would be the skills of thinking deeply and knowing what you're asking for. Because if every single one of you was given a magic lamp with a perfect genie, are you sure that you would have a good impact on the world? Are you sure that you're ready? Are you sure that you think deeply enough about the consequences of what you're asking for? Are you able to test what you've made before you release it? Those are the skills that we need to cultivate. Not blind excitement about these magic tools. They're pretty exciting, they're fun. We can do a lot with them. And of course, if you are the only one who's going to be affected by whatever you made, you are welcome to sit with your magic lamp in your little closet and, play with it, do what you like. But the thing about these systems and tools is they do scale, they do amplify us. I hope that they amplify our intelligence, not our stupidity. There's a lot of work that we have to do to build new digital trust habits and to understand how to test reality and not fall for magic tricks. As far as AI coming for your job, I hope you've all heard this one. AI is not coming for your job. Someone using AI is coming for your job. Yeah. Because these tools do make us more productive. They make all of us more productive if we know how to use them right. Of course, if we're trusting blindly, they can make all of us less productive. But if we have the right trust habits and we have the right curiosity, we can do so much with these tools. But when people ask, what jobs are we going to lose? It's not about jobs, it's about tasks. Every job, no matter how junior or senior, has tasks in it that can be automated. And so when you analyze things, you should ask yourself, how much of my work is repetitive, digitized, and it's easy to know what the right answer is. The more you have those three, the better of a target that task is for automation. And so that could be wonderful. Maybe you don't like that aspect of your job and you are freed for more strategic, more creative, more empowering work. But are you ready for that kind of work? Have you taught yourself to love that kind of work? Do you love novelty, ambiguity, change, innovation? These are beautiful words. Exciting times, opportunities, sometimes threats, challenges. And at conferences, that's the theme. Yay! Innovation, creativity, novelty, etc. Are we truly ready, and do we have the mindset that we need in order to exist in a world where that's what we spend most of our time on? I think we can rise to meet that challenge, but the first step is understanding that it's there. And back to testing. When you write the most important email of your life with ChatGPT, are you just going to send it when it's in a language you don't understand? Right? You can see that there are people who would. They're like, oh, AI, it's intelligent, off we go. But you all now understand that AI makes mistakes. This could be great. Maybe it is, maybe it isn't. So you need to have the skills in order to check. You need to have the relationships with people who could check for you. Trust is going to be a very different thing as we move into this future. Everyone is going to be reaching for more with these tools. And yes, there's so many problems we haven't solved yet, so many inefficiencies damaging the climate, so many diseases we haven't cured, so much art we haven't made. Hey, there's a lot to do. We're going to run out of things to do. But as everybody reaches for more and uses more and more complex tools, their own process plus the complex tool together is a very complex thing. How do you trust that they know what they're doing? How do you collaborate across complexity? Those are the questions that we should be asking. And of course, a quick philosophical one to drive home you don't get AI trust by reading how it works, is this: if I force you to go to Mars, I'm so sorry. Elon Musk chose you got no choice. You're person number 1 on Mars. But you get to choose between 1 or 2 rockets. The first one, you get a stack of physics up to here, explaining all about how it works, all the equations. And you can read that. But it's never flown before. The second one, nobody knows how it works. But it has successfully flown in conditions like yours 10,000 times. Which one do you choose? Now, this is a philosophical question. Again, a bit of a recovering statistician here. I do have a preference. But my preference above all here is that you would start demanding, what do you mean conditions like mine? How was it tested? Show me the testing. Show me what it was built for. Those are the questions that you should be asking. That's getting to the core nature of the thing. And then, if satisfied, they're both a risk. If satisfied, you take that one. That's how it's going to be with AI as well. And with all complex technology, where you cannot read how it works. And whenever we have these tools, these explainability tools, that's like saying, here's a book. I don't know, nice, big, thick one. Boil it down for me to a tweet so it makes sense. The book and the tweet are not the same thing. So, I leave you then with this thought. These tools are going to be helping us write code. And hopefully we will be pretty good at checking that code before we push it to production. Right, engineers? and having a whole new standard of tests. But as we start to do that, what's going to happen is the boring and repetitive parts in the engineer's job are also going to be reduced, which means that we get compounding innovation, because some engineers will use their new opportunities to reach for more new areas, but there are no solutions. But some engineers are going to reach for more better tools and reinvest into better and better ways to automate. That is a snowball effect. That means we are going to have accelerating innovation. We're going to have an accelerating pace of change. How do we prepare for that? It's coming. Learn to love the things I said before. Learn to love ambiguity. Learn to love change. Be excited and curious. Reach for more. Why make every day the same as every other day? It's happening whether we like it or not. So we may as well jump in cheerfully into this revolution. So are we ready for the challenge of complex technology? Where it's not going to be about reading how it works, it's going to be about asking, what am I trying to do with it? And how would I know that what I'm doing is wise and right and working for me? Are we up to this challenge? I think we could be. I hope we are. I hope all of you are at least a little more ready for this, a little more excited. I think we can do it as a species. But we have to learn to love complexity if we're going to. So I leave you with the Kozyrkov criteria. With any AI system, the most important questions you can ask. They're all equally important, that's why they're 1, 1, 1. What's it for? What data is it using? How do we know it works? The 3 most important questions. So much easier to answer and think about than, oh my goodness, what is this backpropagation? What is this math? So thank you very much. If you had fun here and you want to reach out, be in touch. This is my info. And yeah, now we get questions.
I've seen a lot of keynotes, and throughout the past couple of years, I've also seen a lot of keynotes live. And both online and also live is even more. I also stumbled on my way on the stage. Your deliveries are mesmerizing because it's heavy content, it's heavy text, but there's a way of you swaying and through this content, and it was really a pleasure to watch you and to really grasp a lot of ideas. You asked a lot of questions, so our mission now to try to figure out better questions to ask you is harder, but I trust that our audience has been prepared so far and has prepared now as you spoke. I would have one question. If you would have to narrow it down to, I don't know, 3 top things that a company should do to be better prepared for decision intelligence without necessarily being statisticians and psychologists or, I don't know, economists. What would they be? These 3 things, just jump right onto it.
Okay, well, the first one is super basic, but the more red tape you have and the more clunky your processes are, the more you're going to be behind in everything. Because if before it took 2 years for something new to come out, let's say computers in the previous century, now something new might be coming out every month, every week, every day. And if it takes you 6 months just to implement, that's not going to work. So 1 is your processes have to be nimble enough to react. Number 2, new trust habits. And new trust habits, we talked about those for individuals. Trust habits for a company means not just statistics, but also security. I mean, look, you have a lot of AI vendors who, if you go on LinkedIn and you look up how many people there have security in their job title and you realize that's 0, that's kind of scary. right? If complex systems are allowed in and unsecured, you could have all kinds of fun you don't want to have. So don't be too trusting and have ways of navigating those complexities. And then the third one is a new standard of excellence for leadership. And that really should be the first one, but I'm sort of ending on this note, that as we see these tools get better and better, what we realize is that it demands more from us. We have to bring more of ourselves. If you're handed a magic lamp, if there's only one magic lamp in this room, I would beg for that lamp to be given to the person with the best decision-making skills. The person who is wisest, who will think through what they're asking for. And are these skills that we intentionally cultivate? So often we treat decision-making as just, well, that's just something you do. We should be aggressively investing in making ourselves better so that we, the bottleneck, are ready for this incredible innovation.
I know that you said in one of your talks, or it was a debate or a panel or dialogue, that in decision making, what you have to think of first is what would it take to change your mind. I think this is one of the quotes that is really worth just to put it on a wall and watch it every day. We're struggling with education a lot because we have, I don't know if it's the case in New York or in the US, but we have a very monolithic system, and it's like 100 years old, and we're still teaching kids the same ways we used to be taught, and our parents used to be taught, different curricula. But I think now the complexity has grown, but the style is the same, and the kids have to stay in the classroom for, 8 hours and just watch the delivery without engagement. How do you build leaders who make good decisions out of a system that doesn't necessarily innovate in the rhythm of the technology progress?
Well, one is to encourage people to continuously learn. If people think that they stop learning when they graduate, whatever it was, elementary school, high school, college, grad school, if that's when you stop learning, that would be a problem in a changing world. I mean, your knowledge that you have is good for the world that it describes. Just like a good law is good for the context it was designed for. If your world is changing quickly, your knowledge needs to update. Your policies need to update. All kinds of things need to update quite rapidly. So learning to love learning is an important one. But also think about this. If we like to standardize, and it's very easy to test, and the teacher's job is easier when everything is standard, and you can compare and rate people on some tasks. If you give everybody the same stuff, think of what that is as a system. That is a simplistic system in terms of multiple copies, all of the same. We're entering a world of complexity. We can't have such a simplistic system. We need nuance. We need personalization. We need individuals to be contributing differently when interfacing with a system like this. So, education has got to change. It's got to be okay if somebody wants to study the history of the French Revolution and somebody else wants to study the history of mathematics. And all kinds of different, various things should be included in education. Can tools help for that? Absolutely. But that's an attitude change as well.
Unfortunately, in Romania now we're looking a lot into standardizing tests. So it's not the good. I don't know if it's the good. I'm not the one to decide, but at least for my kids, I hate it when they have to study for a standardized test. One question from the audience. As a leader in decision science, how do you foresee the role of AI evolving in assisting human decision making without diminishing the importance of human intuition and creativity? How do you balance?
Yeah, so decision intelligence is turning information into better action, any scale, any setting. When you have better access to information, when you are more plugged in, you can already reach for more when it comes to the quality of your decisions. If you have tools that help you think more broadly, fetch relevant information faster, you become a better decision maker. But the more powerful your tools are, the more you have to improve your ability to think clearly, organize your thoughts, understand what's important and what isn't, be aware of your priorities. All that stuff that's difficult is going to be dragged out of us, kicking and screaming, by the opportunities presented by AI. Now, knowing that, we can stand up straight, put our shoulders back, look cheerfully towards the future and say, fine, let's reach for more then. There are so many things that we haven't done yet. Humanity has a lot to fix. And if you actually jump into any of the broken areas, you're going to wish for automation and help and the ability to structure your thoughts. We need that. That's how we make progress. So I'm excited for us, but it is absolutely going to force a higher standard from us.
And one last question. And this is also, I think, on a thought that I heard you say, that we are the architects of the AI so far.
Well, the question I don't know if you are asking this one, is a big part of all this is going to be the question of who. Who is in charge? Who gets to set the parts that are subjective? Because AI is a big fat subjectivity sandwich with a little layer of math and code in the middle. That part looks subjective, but the whole thing is subjective. But hey, all kinds of things are subjective. The fact that we have chairs in here, that's a subjective societal design choice, saying that nobody cares about back pain. You gotta focus. So technology has a lot of subjectivity in it. The question is, who gets to decide? Who is the architect?
Well, this question that I was talking about, I think it also taps into that. It's also coming from the public. I have a small company. What should I do first? Create a data-driven culture or a human-driven culture? How is ethics coming into this?
Oh dear, should I buzzword or should I buzzword? Take a breath. Figure out, without any of the buzzwords, what you're trying to achieve in your culture. What on earth is data-driven? I hope we're not worshipping some numbers. They are, just some stuff someone decided to write down somewhere. If data-driven means to you that you use the opportunities presented by data when those opportunities are appropriate, that seems nice. And there's no reason that's incompatible with putting your humans at the center of what you do, because what other purpose is there than our fellow humans? And where do ethics come into it? Everywhere. That's where it starts. That's where our priorities come from. So forget the buzzwords. Figure out what you want. Get that vision clearly. And then figure out, pick and choose, which buzzwords are going to help you meet that vision.
Wonderful. If there are more questions, I could stay here for way longer, more than a couple of hours. Cassie has a train to catch, so we need to say goodbye for now. But as before, as in Riaz's case, I'm waiting for your questions if you still want to ask them, and we'll make sure they reach Cassie. Thank you very much.